So from here we'll do number 1. Number 1 says an oxide of chromium is found to have the following percent composition. It's telling us that we have 68% of chromium and 31.6% of oxygen. Determine this compound's empirical formula. So in the previous, in the handout behind this page, right, we just did percent composition, and we figured out how to do percent composition. So then now what we're going to do is we're going to find a formula. This empirical formula is the most simplistic and the most the smallest ratio available of atoms. Okay, so what we're going to do is, you see those percent signs, we're going to change them, because number 1 tells us that we have to change percent to grams. Okay, so we're just going to change it to grams, and percent we're going to change it to grams. So instead of having 68.4 percent chromium, we're going to have 68.4 grams of chromium, and we're going to have 31.6 grams of oxygen. All right. So the next thing that we're going to do is we have to determine the molar mass of each, and we have to divide, right? Since you have the grams now, which we do, now we're going to change from grams to moles, and we got to divide by the molar mass. So the molar mass of chromium, all right, it's in the first row, transition metals, element number 24, has a molar mass, so we're going to divide by the molar mass, which is 52 grams of chromium over 1 mole, under 1 mole. All right. Here, we're going to have 31.6 grams of oxygen, and we're going to divide it by the molar mass of oxygen, which is 16. All right, so now we got to do the math. 68.4 divided by 52. And we end up with 0.975. Now give yourself a bit of numbers, because some of these numbers are going to be very close to one another, so we have to extend the numbers just quite a bit, the precision. And then we do the next one, divided by 16. This one we're going to end up with 1.975. Okay, and now remember that both of these are moles. This one of chromium and this one of oxygen. Now the third step says that once you have the moles, you have to divide by the smallest number of moles, and which one of these is smaller? This number is smaller. So therefore we're going to divide both of these numbers by 1.31538. Now they're going to give us, hopefully, close to a whole number. Of course, since these are the same number, that's going to be 1. The next one is going to be 1.975 divided by 1.31538, and we get 1.5. Now 1.5 is not a very good number that we want, okay? Because it's very far away from the actual whole number. So what we're going to do is we're going to find a number to multiply these two by, so that 1.5 is no longer 1.5, it's close to a whole number. So if we multiply both of these by 2, we end up with 2, and 1.5 times 2, which is what? 3. Okay, so now you see those numbers, we have 2 and 3. Well, now all we're going to do is find a formula, because that's what we're looking for. We're going to put CR, and we have how many of them? 2. So we're going to put CR2O, how many? 3. So this is my empirical formula. All right, and that's number 1.